With the expressions for electric field of dipole available at equatorial point, let us now try to compare how the electric field of dipole at some axial point differs from that on equatorial point. So now we know that at axial point, if you want to find out electric field, the electric field is given as 1 by 4 pi epsilon 0 dipole moment times 2r upon r square minus a square whole square. What is r here? R is the distance of the point from center of the dipole. And what is the expression for electric field of dipole at some equatorial point? At equatorial point you can find out the electric field by using this formula where you have minus 1 by 4 pi epsilon 0 vector p upon r square plus a square raised to 3 by 2. Once again, what is r here? R is the distance of the point from center of the dipole. And as now we know that most of the time this a is very small as compared to the r, and so if we neglect a, the electric field at axial point can be expressed as 1 by 4 pi epsilon 0 2 times dipole moment by r cube. And similarly for equatorial point, if we consider that the a is very small and if we neglect it, we get electric field at equatorial point to be minus 1 by 4 pi epsilon 0 dipole moment upon distance cube. So in either case we have r cube in denominator, so we can say that electric field at axial point, only magnitude if we consider, it is proportional to 1 by r cube. And same is the situation on equatorial point. There also if you consider only magnitude, intensity or magnitude of electric field is proportional to 1 by r cube. So this comparison makes us realize that electric field of dipole on axial point is double to that on equatorial point if we consider the points to be at same distance. And how do we know that? Look at this second equation. You have 2p here, whereas on the corresponding equation we have simply p. So we can say that on axial point you have double electric field as compared to equatorial point at same distance from center of the dipole. What is the other point of comparison? That here we don't have, on axial point you don't have negative sign, it is plus, whereas in case of equatorial point you have minus. What does it mean? That on axial point the direction of electric field is along the direction of dipole moment, whereas if you are at some equatorial point the direction of dipole moment and direction of electric field both are opposite. So that is the second difference between the two electric fields. But then you have one similarity also. What is the similarity? Similarity is that if you look at the nature, how the electric field changes with the distance, then that nature remains same. We can say that in either case, whether you are on axial point or on equatorial point, the electric field varies as 1 by r cube with distance. And that is the similarity between the two electric fields. Let us also try to compare electric field of dipole and electric field of point charge. Now we know that whether you are on equatorial point or on axial point, the electric field of dipole varies as 1 by r cube, where r is the distance of the point from center of the dipole. Whereas in case of point charge, the electric field of point charge varies as 1 by r cube. The expression is kq by r square. So we can say that it is proportional to 1 by r square. Now this is the only difference between electric field of dipole and electric field of point charge. And what these expressions tell us? These expressions tell us that from dipole, if you go away slightly, electric field decreases faster. It changes as 1 by r cube. Whereas for point charge the variation is proportional to 1 by r square. So electric field does decrease, but not as fast as in case of dipole. Electric field of point charge decreases slightly slowly if you compare it with the decrement of electric field of dipole, and that is the only and important difference between electric field of dipole and electric field of point charge.